Hello and welcome to this first lecture of the new section on GenAI model in this course, Mastering Generative AI. So, in purpose of this section is to start giving you an in-depth view of GenAI models. And in this lecture, we will talk about the GANs. In the next ones, we will talk about VAEs, and the third one, we will talk about the transformer models. So, let's take a look at GANs, Generative Adversarial Networks. So what do you think are GANs? Any thoughts on what is GANs? Generative Adversarial Networks. So what are these models? So basically, as you see here, the GANs consist of two neural networks, a generator and a discriminator. They work together in competitive setting to produce realistic data. Now, the GANs are a class of machine learning frameworks designed by Ian Goodfellow and his colleagues in 2014, about 10 years back. And GANs are widely used for generating synthetic data that is nearly impossible to distinguish from real data. They have revolutionized the field of generative modeling by introducing a novel approach that pits two neural networks against each other in the process known as adversarial training. Let's take a look at some more details of the GANs. How do the GANs work? So there are the two core components of GANs, generator and discriminator. Now the generator's role is to create a synthetic data from random noise, synthetic data from random noise. And it tries to produce output that resembles the real data on which it has been trained. So that's what it tries. And obviously, the aim or the goal is to fool the discriminator, other competitor, the other player in the game, into believing that generated data is real. Now, what does discriminator do? Now, the discriminator's role is to evaluate the authenticity of the data it receives from generator, right? And it distinguishes between the real data from the training set and the fake data generated by the generator. And then obviously the goal for discriminator is to accurately classify the data as real or fake and feed it back to the generator. So that's how they work together. Now, how do these GANs work? The generator and discriminator are trained simultaneously, but with opposing objective, and that is what is called an adversarial process. Now, what are these opposing objectives? The generator tries to create increasingly realistic data to deceive the discriminator. And the discriminator tries to become better at identifying real versus fake data. So that's how this adversarial process happens in GANs. Now, during training, the generator produces a batch of synthetic data, uh, and the discriminator evaluates both real and synthetic data, calculating how well it can tell them apart. The discriminator provides feedback to the generator, indicating how realistic the generated data was. And generator uses this feedback to improve its output, making them more convincing over a period of time. So this iterative process continues until the discriminator can no longer reliably distinguish between the real and the generated data. So that's the training dynamics of GANs working. Now, what are the applications that GANs can produce? What are the things that they can do? They can create realistic images from scratch, including faces, landscapes, and objectives. They can convert images from one domain to another, such as turning sketches into photos or daytime sketches into nighttime scenes. They can enhance the resolution of images, making them sharper and more detailed. They can generate additional training data for machine learning models, especially when real data is scarce. And they can apply the artistic style of one image to another, blending content and style from different sources. So a lot of new generation can happen, as you can see here. So what are the advantages and limitations of GANs? Now the GANs advantages are one in terms of its high quality output. GANs are known to produce highly realistic and detailed synthetic data. And they can be applied to a variety of range of dynamics, including images, videos, audios, and text. Can you believe this? And they enable creative and novel applications such as creating entirely new artworks, generating synthetic training data, and enhancing existing media. What are the challenges and limitations of GANs? Uh, the GANs can be difficult to train, often requiring careful tuning of hyperparameters and network architecture. Now, what are these hyperparameters and network architectures? Hold on, we will talk about them as we go forward. Have some patience there. Then they can also a scenario where generator produces limited variations data, and that reduces diversity, and the mode collapse can happen there. So a mode collapse is the situation in which generator produces only limited variation of the data, and they are resource intensive. Training GANs typically require substantial computational resources and large data sets. So GANs are a groundbreaking approach in the field of generative modeling, enabling creation of highly realistic synthetic data across variety of domains. And despite their some limitation challenges, their ability to produce high quality outputs has made them a pivotal technology in both academic research and practical applications. So having looked at GANs in this lecture, what do we do next? We will look at another type of generative AI models, that is VAEs, variational autoencoders. What those are, we will take a look at them in the next lecture. So thank you so much for watching this Gen AI model first lecture in this course, Mastering Generative AI. I hope you are continuing to learn new things, continuing to enjoy. And I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and also download a PDF file to take a look at anything that is of specific interest to you.